Now we have this, as we have said before, we rightly said before, that chemistry practical is a fundamental principle in acknowledging the way chemistry is being run. Chemistry practical is very, very fundamental as far as chemistry is concerned. Unlike, or just like physics, chemistry practical is very, very important. There is no how you can pass chemistry exam without you having practical at least 40, let's say at least 40, because the maximum mark is 40, let's say at least 25. And when you are on the safer side of the league of 25, 40, chemistry practical is very, very important. It's very, very important. Like we have already told our students, we have been telling our students that chemistry practical is very, very important. Now this is Don-Electro-Tech. We are responsible in teaching you the practical related problems, chemistry problem, physics problem, mathematics, and also some of them that we are defining challenges in. Now we are bringing to you this morning, this afternoon, this evening, the chemistry practical, likely Waec question 2025 practicals, titration and volumetric analysis. This question is very, very important in as much as every year we always observe it in chemistry exam, especially practical exams. This question is unavoidable. It must surely come because this is one of the best questions Waec normally set in exam. It is a fundamental. I mean, it is the first question. They always come as question number one. It cannot escape it. So a student that is not properly educated in this area will always fail. And when you fail chemistry, my brother and sister, I don't think that they if you like write home 70 over 60 over 60 in the main exam, you are not going to pass because nobody is 100% correct in life. So that's why I cannot get 60 over 60. So if you have to do your chemistry practical very well, at least you're on the safer side of getting your B or A. That is why we are bringing to you this particular problems. Now this is not a lab. I'm just doing this in my home, in my house. So when I go to the lab, when I get to the lab, I would like to do the practical. You will visualize it with my students how would this practical have been run, and when you see this practical, you be able to handle it because Waec is changing drastically. The policy this year have totally changed. My practice have been put on a high alert that they want to reduce practice. The level of my practice in schools today. That means Waec have brought another policy where a student sitting on the exam hall don't have the same questions. They have changed the questions, so there is no how you can copy another student's script because of what? Because the questions are not the same. So if you are not informed, you are deformed. That is why you need to take this very seriously. Know this, especially the science students. You know this very, very well. Now let's go direct into the question. Now look at the question. We said that the question says all your bullet readings, initial and final, as well as the size of your pipette, must be recorded, but no account of your experimental procedure is required. All calculations must be done in your answer booklet. A solution A is a solution of tetraoxosulfuric acid containing 9.80 gram 9.80 gram of acid per dm cube of solution. Full stop. Solution B was prepared by dissolving 13.8 gram of carbonate, that is X2. This carbonate, we're talking about carbonate. Carbonate is carbonate X2. We don't know the actual carbonate that you're talking about. That is why we have X2003, because this X means that the carbonate can be sodium carbonate, can be calcium carbonate, it can be any carbonate. So this X means that the carbonate is unknown, but you can use any carbonate. And 1 dm cube, that is 10 dm cube, which is which is the same thing as 1000 centimeter cube of the solution. Put A into the burette. That means A must be put in the burette and titrate with 20 centimeter cube or 25 centimeter cube of the portion of B using methyl orange. Know that B is the base, A is the acid. Now methyl orange as indicator. Record the volume of pipette. What is the function of the indicator in a particular practical? The function of the indicator is to show you the endpoint, because without an indicator you can't achieve the endpoint. So indicator is always there to show you when the acid and the base have reached the maximum the acting point, the point where the reaction have the, let's say, call it the end point where this reaction have taken place. Anything other than that, that is when you observe a change in color. Record the volume. You have to record the volume of the pipette. You have to record the volume of the pipette, which is the number one question there. You observe that they say record the volume of the pipette used, because we have two types of pipette we can use. We have 20 centimeter cube pipette and also have 25 centimeter cube pipette. So you also have to record the kind of pipette you use, because if you don't record the pipette you use, Waec have their marking scheme. The marking scheme will be based on the pipette you used. So if you someone that used 20 centimeter cube pipette, he got maybe 19.010, sorry, 19.01, and you 2025 getting 19.01. That is called error in reading, and they understand that this student actually copied or was just trying to do what is called try and error method. Now, tabulate your bullet readings and calculate average volume of acid used. That is A. B. From your results and the information given, calculate the concentration of tetrahydrosulfuric acid solution in 1 mole per dm cube. From the results and information given, note that calculate result is different from the information given. Information is given inside that question, and result is what you have already observed from your titration and other things. Now I say from your result and the information given, calculate the concentration of the tetrahydrosulfuric acid. Now that is, we are going to the B side of this question. Now, from your result and information given, calculate the concentration of the tetraoxosulfuric acid solution in mole per dm cube. Number 2, II, which is the II. The concentration of the carbonate solution in mole per dm cube, the relative molecular mass of the carbonate X203, and the relative atomic mass of X. The equation of the reaction is given that as you can see from the question, you can see that the equation of the reaction is given. Now let's dive into the question properly to solve this question to acquire a perfect answer. Okay. Now, assuming we have a table of value, let's say this is the answer. We have a table of value. I'm just assuming these values because I'm not in the lab, so I'm assuming this value. So let's say the volume of the pipette. The volume of the pipette I'm going to use in my lab is going to be 25.00 centimeter cube, and which is approximately, or which is the same as 0.025 dm cube. We don't call 25, we call 0.025 dm cube. Now I have to look at the question. They said that I should what? The question said tabulate your what? Tabulate your readings, tabulate your bullet reading. So I have to plot that table of values for the bullet reading. Now I will now say my bullet readings, final readings. Always observe that you must put their unit. The unit of the volume is centimeter cube, and the initial reading is also taken into recognizance, which is also centimeter cube. That is the unit. Now you have to put your values. Now you have the volume of acid used, volume of A, which is acid used. Volume of A used is the volume of acid used in the same thing. Now we have what is called the rough reading. The rough reading, I'm just doing what is called random sampling. You have what is called the rough reading. The rough reading is not part of the main reading, so you don't use it in checking the average volume of acid used. You don't use it at all, because if you use it, you have error in calculation. So you just need to pull this down and try to picture this out. The final, let's assume that we are doing what is called random sampling. Rough reading, we say 25.08. we have 0.75, and at the end of the day we have 25.05. Here we have 26.15, we have 1.5, 1.45, and 24 point. These values are just a assumption, they are not original. Don't say this is this. I'm just assuming them because I did not perform any practicals. You can see I was just trying to get the values. These values are also obtainable in the lab when I want to do my practicals. Like we're talking about the virtual part of the practical, you see the equipments and the reagents there. So if you see this, don't say how is he getting this value. This value will be gotten when you do the real practical, which I also post in this channel. These are the values. The values are rare for you. You can see them. These are the values. The values are here. You can see the values. So let's work on that now. Since we have gotten the value, and if we look at that question, we said that the question says, look at the question. It says we should do what? We should calculate one. They said tabulate your reading, which we have just done. This is the table of this is the tabulating reading. We have already tabulated our reading, and this is what we have for the table of values. Now another question there says you calculate the average volume of acid here, which is very, very important. Average volume, therefore average volume of acid used, is equals to, don't always see, let me tell you something, that some students always have issue in this area, because sometimes they would like to add a rough value. You don't need to add the rough value. You don't need to add a rough value. What you need to add is the first, second, and the third value. If you did the first titration, second titration, and third titration, so you need to add a value to tap the volume of acid used with the volume of A used, starting from this point. Don't use the rough value. Now you now say 4.70 plus 4.60 plus, let me bring it back here so that you can see it. 4.70 plus 2.40 plus 2.60 divide by 3 average, because we are checking on 1 2 3. So since it is 1 2 3, you divide it by 3. Therefore VA, average volume of acid, is VA. Therefore VA is equals to, when you divide this value, you are going to have the value of 24.60 centimeter cube, or 0.0246 dm cube. So the dm cube, that is what you have to obtain in the average volume of acid used. Yes. Now let's go into the next question. We are the question number B. This is A have been handled. Question A have been handled. Now we're going to question B. Question B1. The question B1 says, what this question B1 says, from your result and information provided given, calculate the concentration of tetraols or supersys acid solution in mole per dm cube. Now, in solving this type of problem, you just need to look at what is the best way of solving this problem. Now, in calculation, we will now say that molar mass of H2SO4, which is sulfuric acid, is equals to 98.0 gram per mole. Yes, that is the mole. Then the concentration of H2SO4 is equal to, giving us because you can see that we have the mass in gram. Look at the mass in gram. You see the mass in gram here. It said that the solution containing 9.08 gram of acid per dm cube. That means we now say that concentration is molar mass. It's called the molar mass all over mass concentration. You are having mass concentration all over molar mass. So we are going to have this mass concentration over molar mass, which is equal to, we are going to have the molar mass. Now, what is the molar mass? The molar mass concentration is given as from the question. You see we have 9.8 grams. So we have 9.8 gram divided by 98.00 gram per mole. This is gram per dm cube according to the question. Gram per dm cube. So when you divide this, we are going to have the value here. This is molar concentration of the acid, which is Ca, is equals to, therefore Ca is equals to 0.100 mole per dm cube. Mole, because this gram we cancel out this gram, mole will always stand, and this will come in. So this is how to calculate the BI. So what the next thing now is to check the BII. Yes, BII. We check the BII, isn't it? Yes, we check the BII. Now, while checking the BII, we'll say, what is the BII? The BII is concentration of a carbonate solution. For the carbonate solution, you need to understand the formula that is involved. What is the formula? The formula is CAVA all over CBVB equals to NA MB. Now, in the equation of reaction, if you check the equation of the reaction very well, the equation of reaction, we have this is acid, this is base, this is acid, this is base. If you watch the mole concentration, their mole, that is the molecule, the mole, that is the mole, the value outside here. If I put 2 here, that means the mole here is become molar mass. Na is the mole, which is 2. But since there is no 2 here, there is no any other value here. What we are seeing here is 1 1. So we have the Na and mb is equals to the molar mass, the molar this thing b is equals to 1:1. That is the ratio. That is the way the chemical reacted, the acid reacted with the base. So now, since we are having 1:1, we have to apply another principle, which is going to give us what we actually need. Going to give us what we actually need, and this is what you have to get now. Therefore, CAVA is equal over CBVB is equals to NAMB. So since NA and MB, NA is equals to 1 and MB is equals to 1, because you check the equation of reaction. Here is 1 here, that is also 1 here. So that is their balancing ratio. That is the balancing ratio of the equation. Now we will now say that CA is already given. CA is already given from what we calculated. This is our CA here. We already have our CA. This is our CA. So therefore, anywhere you see CA, you put the value of 0.100 times VA. VA is the volume of acid. What is the volume of acid here? The volume of acid is 24.60 all over. CB is not what we are looking for is CB. We don't have the concentration of base. We are looking for that. Then VB is the volume of what? Base. Volume of base. And what is the volume of base? The volume of base is what we have in our pipette. The pipette reading is the volume of base. The volume of base, look at it here. This is the volume of base. The pipette reading is the volume of base. Pipette reading. So since we already, the question is in dm cube, so we also have to use the one that I have in D, that is in dm cube, that you have 0.025, because we have been converted, is equals to 1/1. So you cross multiply. When you cross multiply, this is more mathematics. Just cross multiply. You have 0.10 times 24.60 times 1 is equals to VB times 0.025. At the end of the day, we have that CB is equals to this simple mathematics. Now you can handle this. So you have times 24.0 this times 1 divided by 0.025. Therefore, CB is equals to, CB now gives us a 0.098 mole per dm cube. This is what we have here. So we have this as this per dm cube. Now, if now go to the next question, we say the relative molecular mass of carbonate X. So for look at it here now, they were trying to check the relative. See, if you are watching this video, you just need to understand that you need a paper to copy out the questions. Now, the relative molecular mass of the carbonate, which is this molecular. This is molecular symbol that you're seeing here. The molecular formula you're seeing here. Now you have the molecular formula as X2CO3. Now, how do you check the molecular mass of that kind of value? In that context, we'll now say that if you are not considering this question number 3, we'll now say that from CB, the CB is 0.098. Now, therefore, 0.098 mole of X2O3 contains 13.8 gram. Look at the question here. You see 13.8 gram in the question. We have 13.8 gram. Look at it here. 13.8 gram here in the question. We have it here. This is 13.8 gram. So at that point now, we'll now say that 0.09 mole of this. 0.09 mole of this contain 13.8 gram. Then 1 mole. How many will 1 mole of this contain? 1 mole of this is going to contain what? It's going to contain. Contains what? We don't know. Call it X. Call it S. Therefore, you cross multiply this. That means 0.098 is equals to 13.8. Therefore, 1 is equals to X. So you cross multiply this. When you cross multiply, you have 1 times 1, 13.8 is equals to 0.098x. Divide both sides by x, which is coefficient of 0.98. Therefore, we have x is equals to 13.8 divided by 0.098, which is going to give us 141 gram. This 141 gram is the relative molecular mass of carbonate X. Therefore, X203 is equals to 141 gram. Simple. So this is very simple. And the last question there says that relative atomic mass of what? X. Relative atomic mass of S is very simple to solve. To solve relative atomic mass of X, relative atomic mass of S, relative atomic mass of X is very simple. Now, how do we solve relative atomic mass of X? Relative atomic mass of S is gotten from this. Now let's consider this. Now let's say that we have a let the relative atomic mass of X equals to S, small s. This is capital S and small x. Now we'll now say it because from there we have X203. So if this is now we're now having 2x plus 2x plus bracket carbon is 12 from the look at this. We have this from this question. We have this carbon is 12. We have carbon is 12 here, and sulfur is 32, oxygen is 16, hydrogen is 1. So when you have this now, you can see that say hydrogen is 1, oxygen is 16, sulfur is 32, and carbon is 12. So anywhere you see carbon, this x doesn't have any value, so we are looking for this x. You can even use the capital X like that without even changing it to small x. So you can say 2x plus carbon is 12, so you put 12 plus what other thing is there is oxygen is 16, and also how many oxygen is there is 3. So 16 times 3 is equals to 1, the atomic molecular related atomic mass. So here going to give us 2x plus this time give us 12 plus 48 is equals to 141. So you have 2s is equals to 2s is equals to this 48 plus again to give us this figure 60 is equals to 141. You collect like 10, isn't it? Now you have 41 minus 60. When you cross over, you have 2x is equals to 81. Therefore, x is equals to 81 divided by 2. S is equals to what? 40.5. This is the relative atomic mass of x, and that is how to solve this kind of question whenever you see it in exam hall. It is very simple. Titration is one of the best topics that you can handle. It is very simple. Just follow the principle, understand some of the formulas that is very important in solving such kind of problems. These formulas are very, very important. When we talk about concentration, formula for concentration, you can say mass concentration in gram per dm cube all over molar mass. Very important. Thank you very much for watching. Try to comment, try to share this video with your friends, invite them to this channel so that they will also learn. There are many things to bring to this channel, but I'm going to post the video on how to practicalize this thing in lab. You see the chemicals that are involved and see how to run these practicals. Thank you very much. Like, comment, and try to share this video. That is how we do it.